Hi, so welcome back to the channel and to a slightly different video format. So this series called Starting Sciart will be slightly different from the tutorials that I've been putting up previously, which have been focused on specific concepts or topics in Blender. Starting Sciart is meant to be a series of videos that take you through the full workflow. These videos are meant to be slightly easier to follow, more accessible for people who are maybe just picking up Blender so that they can see where to start and how it gets to the end, hence the name Starting Sciart. For this first video, we'll be creating this, which is a field effect transistor based biosensor. The way that these biosensors usually work is that there is a source and a drain, and there is a channel material in between, sitting in a aqueous system, and the current through that channel material depends on the voltage that the gate applies. And so in this case, the channel is functionalized with a bunch of antibodies that are the recognition element. So we're going to see how we can model all of this together, all the way from start to the final rendered picture. So let's get started. You'll need to download two assets to follow along with this tutorial. Both of them are made by CGFigures or Germanium, which you can get for free on his Gumroad. The first asset that you're going to need is the basic layer builder, and the second one is the transistor metal dichalcogenide layer builder.
So to get started here, I have a very basic scene, just a backdrop with a cube. I also have some light already going on in the scene in the form of an HDRI, Brown Photo Studio 2, set to a strength of 0.8, also with a slight lead rotation of 200. The first order of business is to get rid of the default cube, so go ahead and delete that. And we want to go ahead and add in the two assets from CGFigures, the layer builder and the transition metal dichalcogenide assets, to start building our scene. If this is your first time using the asset browser, you'll need to set that up. To do so, just come to Edit, Preferences, scroll all the way down to File Paths, and under Asset Libraries, there is a designation path where you can keep all of your assets stored. Go ahead and download the assets from the CGFigures Gumroad page and put them into that directory. I've already done that, so I'm going to turn all of these windows into the asset browser. And so I'm going to go ahead and add the default layer stack and the metal dichalcogenide asset. So the first thing we're going to do is make the different layers of the transistor using the layer builder. Let's go ahead and hide the TMDC for now. So the way that this asset works is that it uses geometry nodes to create these individual layers. So we're going to need to play around a little bit in geometry nodes. So a full in-depth tutorial on how the layer builder works can be found on CGFigures' YouTube channel. I'll put a link in the description box so you can find out more about how this asset works. But all you really need to know is that there are these layer builder groups which are responsible for creating each of these individual layers. In our case, we only need 3 layers, one for the silicon base, the silicon oxide insulating layer, and the layer to build the gold contacts with. So we can remove some of these extra layers. I'm going to go ahead and mute 2 of the layers. Just for housekeeping, I'm going to move some of these to the side so we can just focus on these 3 layer builders. So there's only a few parameters that we really need to toggle, although there is a variety of different controls that we can use if we ever were to, say, animate these layers. But the most important ones are the length, the width, and the height. We're also going to use the Boolean cutout option to be able to slice the top layer to create 2 distinct contact pads. And then we also need material. To get started, go ahead and add 2 value nodes. I'm going to use these to drive the length and the width of the bottom 2 layers so that they always match each other. Let's call the first value node length, second one width. And just for good housekeeping, I'm going to go ahead and name these 3 layer builder groups. So the first one will be our silicon, second one will be our silicon dioxide, the third one will be our gold contact layer. So go ahead and take the length value node and plug that into the length inputs for the silicon and silicon dioxide. Likewise the width for the width. And let's set that to something that isn't 0. So how about a length of, say, 1 and 1, just to see what we're working with. Maybe we can make this the length a little bit longer and the width a little bit wider, something like that. Next, we need to create a Boolean cutout option to take away the middle part of this top layer, which will be our gold contact. If that doesn't make sense to you right now, it will make sense in a second. Go ahead and add a cube. And we're going to take this cube as the Boolean object. So plug that into the Boolean object input for the gold layer and select use Boolean cutout. So right now the gold layer completely disappears. That's because the mesh cube is cutting away all of that layer. But if I were to, for example, toggle the size of that cube, we can selectively remove specific parts of that layer. So by changing the X parameter, the X size of this cube, we're basically defining the channel length for this transistor. I might go ahead and make the length of this layer just a little bit longer, so we get thicker pads like this, and I might want to increase the height of these layers just a bit. Something like 0.2, and then 0.15. Great. So the next thing we need to do is apply some material. So I'm come to the Materials tab, and let's create 3 new materials and name them respectively silicon, silicon dioxide, and gold. For the silicon, I'm going to go ahead and use a dark color, something like a dark gray. Let's increase the metallic to 1 and keep the roughness at 0.5. Silicon dioxide, something similar but a lighter gray. Something like this. Again, let's up the metallic. And finally for gold, we want something much more metallic gold looking. So set the color to something orangish. Crank up the metallic and bring the roughness to 0.2. With the basic materials set up, let's go ahead and select them. So this very left layer builder is our silicon. So let's add silicon. Same for the silicon dioxide. And also the gold. So now if we come to the rendered view, we should find that our transistor is looking a bit more like a transistor. Next part is going to be to do the TMDC channel. So let's bring back our TMDC. For this, we don't need very much geometry nodes control, so I'm just going to collapse the window for a second. All I'm going to do is just crudely position it in the correct location, i.e. in between the contacts. So if you come to the Modifiers tab, you'll find a bunch of different controls. We're going to use these in a second. I'm just going to scale up this layer and move it into position. So the first thing we need to do is we need to trim this layer a little bit because it's bumping outside of the contacts. So if I use the X crop value, bring it down, make sure that it sits nicely in between the contacts. You can also play with the number of layers like this. I think in this instance we're going to go with 1 layer. So select 1 layer and move it up a little bit so that it sits nicely above the silicon dioxide. If you wanted a slightly more dense look, we can also increase the number of units by increasing the number of units there. I think I'm also going to bring down the layer height just so that the TMDC layer is a little bit more compact. Be a little bit more. That's looking pretty good. I'm also going to increase the size of these atoms. If I increase both of these to something like 3, 5. Also looking pretty good. We'll need to adjust the height again to make sure that's properly sitting on top of the silicon dioxide. Lastly, I prefer to have the sulfur and the metal color swapped around. So to swap the materials around, I just need to swap around the atom 1 and atom 2 material. So let's have atom 1 being the, well, in this case, molybdenum, and atom 2 being the sulfur. So the sulfur is now yellow and the metal is now blue. Yellow is quite bright, so I'm just going to change the color, being a bit more yellowy. And now that's looking pretty good. So now we have ourselves our basic 2D material FET. Let's go ahead and add some electrodes. So I'm going to have contacts to each of these source and drain electrodes, as well as a electrode to become the gate. I'm going to add a curve path, and in the geometry node editor again, so just pull up the geometry node editor. I'm going to type in contact, k-node node tree, and all I'm going to do is apply a curve to mesh operation, the curve circle section, smaller cross section, and enable fill caps. And I'm going to also add a set material node and select gold, so the same material as our gold contact layer, and position these to come out of the contact, the source drain contacts. So let's first rotate it in the Y, scale the Z a little bit, and now it's just a matter of moving it around. It sits nicely in the center of our contact. What I'm going to do is bend these wires away. All you need to do is tab into edit mode, take the last node and press G to move and move it in the X direction, and then also a little bit of fine tuning. So that's looking pretty good. I might drop the radius of this wire to 0.1 so it's not so obstructive. And since that's looking good, I'll duplicate that by pressing Shift D, rotate it 180 degrees, and just move that onto the other contact. Before I create the gate contact, one thing I will need is the liquid. So let's go ahead and add a mesh UV sphere and tab into edit mode, enable toggle X-ray with face select enabled. You're going to select the bottom half of this UV sphere and delete the faces. This is going to be the basis of our droplet of liquid. Let's disable X-ray again, press shade smooth and just scale it down a little bit and position it so that it sits nicely on top of the channel. Do something like this. I think I might increase the channel length by cutting away more of these electrode layers on the FET. So I'm just going to temporarily come back to the layer builder nodes, and with the cube Boolean object, I'm just going to toggle the X so that we get a little bit more channel length, so we can have some space, make this bubble of liquid a little bit bigger. Also shift the contact wires, accommodate that. So now we have ourselves something like this, and we need to apply a liquid material to the bubble. We should probably name our liquid, although we should call it electrolyte, so you know what it is. And equally for the two curves that become our contacts, to group them into a collection, call them contact connections. So let's add some materials to the electrolyte. Instead of the geometry nodes editor, let's pull up the shader editor and create a new material, increase the transmission, and drop the roughness all the way to 0. We already have ourselves a liquid looking blob. A couple of things you will notice is that the refractive index is extremely aggressive, makes it quite difficult to see what's happening inside. So let's first drop the IOR. I'm going to set it to something like 1.1. You can play around with this as much as you want. Obviously, this becomes less realistic, but for visual clarity, it is important to make sure that there isn't so much refraction happening. Let's also add a slight blue tint to the electrolyte. Maybe that's a bit strong. Something like this. And finally, I'm going to create some ripple effects. I'm going to do this while using bump, which basically fakes the roughness. So add a bump to the normal socket of the material. Into the height of that bump, plug a color ramp. And that, add a noise texture, and provided that you have node wrangler enabled, you can press Ctrl T to add a mapping and texture coordinate node to that noise texture. Instead of generate it, select the object coordinates and put that into the mapping, and you can see that we are starting to fake some roughness texture on the surface of the liquid. This is currently way too strong, so let's drop the strength to something like 0.1, which still gives us our rippling effect, but not too strong. You can go ahead and play with the scale, get the desired effect. If you want something that looks really liquidy, I would suggest dropping the scale down. Let's also add the antibodies that we're going to functionalize the surface of the channel with. Just to make it easier, let's disable the electrolyte temporarily, from out of rendered view. And I'm going to use something called a metaball to quickly model the Y shape of the antibody. So go ahead and add a metaball. So metaballs are slightly different from meshes in that they aren't actual geometry. They're not controlled or dictated by vertices and faces. They're actually based on a bunch of functions. We can actually do a lot of simple modeling by adding metaballs together to create shapes that we want very quickly. So all I'm doing here is taking the metaball, pressing Shift D to duplicate, and taking that duplicated metaball to a new position and extending it upwards. So I'm just going to repeat this process to create myself a simplified schematic of an antibody. So once that's modeled the way you want to right click and press convert to mesh. Now actually convert the metaball into real geometry, which I can see by coming into edit mode. You see it has now actual faces and vertices. Let's rename this antibody. And I'm going to just scale it down and apply scale. Let's also add a material, call it antibody. I'm going to give it a greenish material with the roughness set all the way to 1, so it should look something like this, a nice vibrant fluorescent green. And so now all what we need to do is spawn a bunch of these antibodies on the surface of our channel. To do the distribution of antibodies, I'm going to add a mesh plane, scale it down a bit so that it fits inside the channel, bring it up a little bit so that it sits close to the surface, the top surface of the TMDC, and make sure you apply scale after that. Let's come back to geometry nodes, create a new node tree, and call this antibody scatter. Also going to call this lane antibody scatter. So add yourself a distribute points on faces node and then an instance point. Into the instance socket, add a object info node and select the antibody object as the instance object. So now you have the antibodies distributing on the surface. First thing is that they are much too big. So let's go ahead and add a value node to control the scale. Set it to something smaller, say 0.4. Another thing is that they are currently overlapping with each other, which is not what we want. And we can control that by having, rather than random, pos on disk, and we can change the distance minimum to control how close they can come together before we can no longer distribute points. So have that set on the distance minimum to something non-zero. If you want more of these antibodies scattered around, all you have to do is increase the density max. And you can also play around with the seed value to get different distributions. Maybe something like this will be good. One last thing is I don't want all of these antibodies fixed in the same orientation. I want them to have slightly different orientations in the z-axis. In the instance on points node under rotation, go ahead and add a random value. It should automatically give you a vector type because you pulled out of a vector type socket. And what we want is that we assign a random value between 0 and 2 pi in the z-axis only. So set the max for the x and y rotations to 0, so that there is no rotation there. And in the z value, add 2 pi. And so now each instance of antibody has a slightly different rotation as they are scattered. If we bring back the electrolyte, you can see we're getting quite close. One last thing to model is the gate electrode, so just the electrode through which the electrolyte gates this channel material. And we're going to do something very similar to the contact connections to the source and drain. So all I'm going to do is actually duplicate one of the existing source drain contact connections, translate it towards the center of the device so that it lies above the droplet. I'm going to get rid of the vertex that I was using to bend the connection and just drop that in into the liquid. We will need to add a different material rather than gold, say something like platinum. So let's create a new material, call it platinum. For platinum, we'll leave the base color as white. Again, pull up the metallic all the way to 1, and let's have the roughness drop to 0.2. I only want to apply the material to this electrode, so let's click the display number for the node setup, let's call this the gate contact, and set the material to platinum. And so now we have a different material wire poking into the electrolyte. And we are actually basically done. I'm going to do two things for aesthetic purposes. The first relates to the shading of the materials. I'm going to go ahead and open the shader editor to the left, and all I'm going to do is apply a little bit of bump, give it a little bit of fake roughness effect. So just like we did for the electrolyte, let's add a bump node to the normal. I'm not going to bother with the color ramp, just add a noise texture directly into the height. Press Ctrl T, add texture coordinate and mapping nodes. Again, select object coordinates instead of generated coordinates. So now we get some extremely aggressive bump action going. Let's drop the strength 0.1 and crank up the scale. You can also play around with the roughness and detail. I'm going to set the detail to something like 10, and let's up the roughness to 0.7 or 0.8. And so that just gives a little bit more interest to the material rather than just being a flat shade. Obviously, this is a very artistic choice, and you can dispense with this if you're making an actual figure for a paper. Now I'm just going to repeat the same process for the silicon oxide and the silicon. You can actually go ahead and just select this setup for bump and noise texture. Press Ctrl C. Come to the silicon dioxide, let's say, and Ctrl V to add it into the shader setup there. And just plug that into the normal for that material as well. Let's do the same for the silicon. So there is just that little bit extra interest. Let's go ahead and start setting up the lighting in the camera for rendering. I'm going to first bring the camera in much more closely, like so. I think I currently have depth of field on, but no object to control the focus. So let's go ahead and add an empty and place that somewhere in the middle of the device and call it focus. And let's just control the depth of field of the camera by selecting the focus empty. So let's rotate my backplane in the Z direction to make sure that I am fully facing the camera. You'll notice the antibody is still poking out here. It's okay. It is currently disabled in rendered view, but you can also disable it in the viewport. And another thing I'm going to do is, rather than the light coming from the right hand side, I'm going to rotate the HDRI so that it almost comes from the left hand side. Let's come back to the world shader properties and just play with the Z rotation so that we actually get some shadows towards the right of the device. As you play around with the rotation, you'll probably notice that you get different kinds of effects on the liquid, where under certain rotations the liquid becomes much more believably liquid. Like here, for example, you can actually start to see the rippling effect more easily. And that is basically done. Of course, feel free to play with the camera angle. You might also want to composite some glare into the scene for artistic effect. And so here you have yourselves a nice looking image of a bio-FET sensor. That's basically it. I hope you found this useful. Please like and leave a comment if you would like to see more of this kind of content. I'd particularly appreciate any suggestions of different types of things you'd like a walkthrough tutorial for. Otherwise, I'll see you in the next video, and bye bye for now.